Hi everyone, this is Sam Gabriel, and I'm excited to share with you today a new video regarding Hashicorp Packer. And specifically, we're going to see an example of creating a Ubuntu 20.04 image inside of VMware using Packer. So that later in another video, we can see how to use that image to build a VM inside of VMware with Terraform. Now, in talking to multiple customers, I found that many teams at different organizations have seen the benefits of infrastructure as code, specifically the cloud teams, and using Packer and Terraform in cloud environments such as AWS, Azure, GCP. But then we find that the private cloud teams that have VMware environments on-prem have seen the benefits that these teams, the cloud teams, have gained by using infrastructure as code. So we're seeing a lot more adoption in terms of using Packer and Terraform in VMware environments. And that's why I decided to record this video and show an example of how you can use Packer and Terraform inside of VMware. So again, for today, for this video, we're going to talk about Packer. And in another video later, we'll talk about Terraform on VMware. So let's get started. All right, so let's take a look at the setup. It's very simple. I have my desktop and I have a Packer CLI basically running on my desktop, and then I'm calling out to vCenter, and I have an instance of that in my home lab, and Packer talks to vCenter, creates a VM based on the configuration parameters that I put in place. It takes a little bit of time, I think about 15 minutes or so. And once you have everything going, it's going to create that image for you. And there is really no intervention needed. You don't need to go click anywhere, accept anything inside of the Ubuntu installer or anything like that. And basically, it helps really when you want to automate the process, when you want to self-document the process, and all the benefits that come with infrastructure as code. So let's get started and take a look. Here in my repo, what I'll do is I will just run the command that will get this all to work. And while we're waiting for this to actually finish, I'll explain to you how everything works. So this is the command here I have in my README file, and this repo is going to be shared with everybody, so you can go ahead and leverage that and use it. So let's paste that command here and hit enter. And we're just gonna sit and wait. If you're interested in obviously looking through the logs, feel free to do so, especially the first time. But basically we are now connected into vSphere, and we've asked vCenter to go ahead and create a template for us. So while this runs, I will do a couple of things. First, let me show you what vCenter looks like. So as you can see here, under my templates section, I have a template running called Ubuntu 2004 template, or 2004 basically template, 100 gigabytes thin. So this is currently running right now. It's generating a VM, and it's creating everything necessary in that VM, installing Ubuntu and so on. And if you click inside the web console, you can see it live as it happens inside of the console here. So you can obviously look at the logs here directly in vSphere, and or check the logs inside of Packer. Now there are some obviously some more logs that you'll see as the VM loads and reboots and gets things going. So you might want to check both, at least for the first time, until you're comfortable with what's going on. Okay, so we'll let this run. As you can see here, we're just waiting for an IP to come back. So we're running DHCP server in vSphere, and here you go. We got an IP back, and now we're just waiting for SSH to become available, and I'll explain why that is. But things are going very well right now. So let's bring this down a little bit. I'll explain a couple of things. The new way of installing Ubuntu, especially since 2004, it relies on something called subequity server, and it's a different way of doing things than what we're used to before with a pre-seed file and so on. That was called a Debian, what's it called? Let me double check here. By the way, there is a blog post that I'll be releasing with all this information as well, with the video embedded in it as usual. So look out for that. Yeah, so subequity server installer is the new way of installing Ubuntu. It was available in Ubuntu 18.04, but it was optional. The classic server was called Debian installer. And so the new one uses Cloud Init. The old one used the pre-seed file that I mentioned before, and I had it in a previous video of Packer with Ubuntu 18.04, where we walked through the pre-seed file and showed how that file is used basically for the installation, all the configuration necessary for the installation of Ubuntu. So yeah, so the new way of doing things is moving towards Cloud Init, and with Cloud Init, there are a few things to take into consideration. You can see here the HTTP folder. It has two files: the metadata file, which is empty for an on-prem installation, in our case in VMware, so we don't need to put anything there, but we need to have the file there nevertheless. If you're running this in cloud, then you can add some metadata in here. And then the other file is called the user data file. So in here, there are a few things that you can take a look at. So you can see here that we can have some early commands in the very beginning, and actually in this installer we stop the SSH process, because we found that Packer somehow times out, thinking that it's still waiting for SSH to become available. As you can see here, it may time out, so it's better to shut this off. And once the machine restarts, the SSH process is going to come up automatically. So that you can run a bunch of early commands in this section. The other things, as you can see here, some of the configurations around the keyboard. You can also install packages. As you can see, we have a bunch of packages that we're installing here as part of Cloud Init. Some network configuration, some identity configuration, and notice this one here, this password. To get to that, I have it here in the README file, how to create that. I can actually show you how to do it. If you open a new terminal, I have the commands here. First thing is make sure you have whois installed. Once you have that, we're going to use the mkpassword utility. So if I copy that, and let's paste that command in here, it's going to ask you for the password that you're trying to hash or encrypt. So if I type say Ubuntu, hit enter, it will come back with a hash like you see here, and that is what's needed. So you can copy that, and that's what's needed to be put inside this user data password field in the identity section. After that, you can see the SSH section where we're allowing password yes, install server yes. This is the public key that is needed so that you can SSH into this box once it's created. So you can push the public key or put the public key here. And then storage section, and then some late commands that you can have at the very end. It's pretty straightforward. So you're adding this Ubuntu user to the sudoers file. You don't need the password to issue the sudo command. So that's the first section to notice in our configuration, this HTTP folder. The second piece is a scripts folder, and these scripts can run at the very end after Packer has completed its run. Let's keep it here so we can see if it's done. But here's an example of a script that you can run at the very end in the provisioning section of Packer. So you can see a few things. One important thing to do is to make sure that you clean the machine ID, so you're able to clone that image later on as you're creating that VM. So these are the commands to do so. For my particular use case, I'm using I'm going to create a K3s installation, a master, and a few worker nodes. This is a version of or distribution of Kubernetes from created by the Rancher folks. So it's a stripped down Kubernetes distribution that's very suitable in lab environments, small environments, edge environments, even on your Raspberry Pi and so on. So some of the requirements there, adding iSCSI, daemon, getting it to restart NTP, and so on. If you're using Longhorn specifically for storage. Other things that we need to take into consideration as well, such as making a directory for DHCP. And some of these things, I added them because the Packer install will fail. And then I go Google and find out, okay, why did it fail? Oh, it's because of this thing that needs to be added. So some of these things I had to add. So this is all based on a lot of research, a lot of hours spent to get this to finally work. But once it works, you're good to go to reuse it over and over again. So don't be discouraged if the Packer run doesn't succeed from the very first try. It didn't for me. It took me good over 20 hours to get this finally to work, especially since it's using the new, like I said, Cloud Init version with 20.04. So don't be discouraged once again. You'll eventually get it to work. But this one works. It's tested, and in the blog post I'll put all the instructions if I miss anything here in this video, so you can follow along. You can also see that we're installing Docker in this case. I want this template to have Docker so that whenever I use Terraform to spin up VM based on this template, it already has Docker installed. All right, so that's one script. I have another script as well. It's the same exact thing, except that I'm not installing Docker. The reason for the difference is that one with Docker, I actually used it as a VM to run GitLab in, as a GitLab runner inside of it. Whereas the other one is going to be used for all my K3s machines, so the master and the workers. Okay, so that's the scripts. The other piece that I want to show you is that I have two versions of this Packer template. Basically, the first one is based on the old way of running Packer with JSON. And the second one is using HCL, which is the Hashicorp configuration language. The preference, or my preference now, is to move towards the Hashicorp configuration language, HCL. This is the same language that's used for all of HashiCorp's tools, such as Terraform and Vault, Console, Nomad, and so on. And that's definitely the direction that Hashicorp is taking Packer, so might as well get on board with that. So what I'll do is I'll walk you through a couple of files here, the HCL ones. But again, this has been tested for both the JSON version and the HCL version. So basically what you need here is this HCL main file, and then a bunch of variable files. One here, this 100 gigabyte disk, this 650, and then an example file where you can put all the secret information that you need, which is basically the credentials that you need to get into your vSphere environment. So I also have this example ready for you to look at in the repo. Obviously remove this example keyword, I guess, and then you put your own secrets in there, but make sure you don't check it into your Git. So as you can see, my Git ignore here, I'm ignoring the variable secrets.json if you use the JSON version, or the vSphere Packer vars HCL, which is this one. Okay, so let's take a quick look at this main file here and see what it's all about. In the very beginning, similar to Terraform, if you're familiar with Terraform, it's a very exact same syntax in terms of defining variables. So you can see vCenter username, vCenter password, and so on. So I have a bunch of variables that are defined at the top of this file. I'm not going to go into each one of those. They're pretty easy to follow and understand. There's a locals variable here to be used for basically a build time that you can attach in the notes section of that template. And then there's the source here relying on vmware-iso. and we name it Linux Ubuntu server. And here we attach a lot of these variables that we kind of defined before, vCenter server, username, password, data center, and so on. Here's the notes section where we can say built by Hashicorp Packer on specific time. Defining storage, network adapters, the URL for the ISO image, where actually the base image, the base Ubuntu image, where we're grabbing that from, checksum, an HTTP directory, which is the actual directory here. CD files, this is, we're going to be mounting those two files, metadata and user data, using CD-ROM inside of vSphere. Boot command to get things started. The SSH password and username, and so on. Finally, the build section, we call on our source. We call on our source vsphere-iso Linux Ubuntu server, which is what I just showed you here, vsphere-iso Linux Ubuntu server. And in here, I have a provisioner, and this is the provision that's going to run after everything is complete, to SSH into the machine and run the scripts that I mentioned before. So the scripts that are in here, you can see it's referred to here. Okay. And that basically concludes the main HCL file to get everything running. Now we can take a look at the variables files. I have two of those. The first one is this one, which defines, or assigns I should say, all the HTTP directory and all the VM settings. So what the name of the VM is going to be, or the template I should say. So this is the template that will end up showing inside of vSphere, which is what we're already seeing as it's running. The type of VM guest OS, the version, and a few other things. In addition to that, I'm already showing the disk. So this disk size is 100 gigabytes. This one here is going to be 650. And the reason why I have two is one is going to be for my master K3s machine, and the other one is going to be for my worker nodes. The provisioning type is going to be thin provisioning. You can also change that to thick provisioning if you wish. SSH username and password will be Ubuntu. And here is where I define the ISO file and the checksum, and also where I'm grabbing the Ubuntu ISO from. Okay. And finally, the shell scripts that I'm going to use for this machine, which I'll use with the master node, is going to run, in this case, Docker, for example. And then finally, the last file that I want to show you in terms of variables is this vSphere PKR or Packer vars example, where we're looking at the credentials for your vCenter or vSphere in general. Obviously, these are not mine. I just put them here as an example, and then also how to connect to vCenter. So the IP address, the name of the data center, the name of the data store, network, the folder, and so on. And that's pretty much it. I can see here that the build has successfully completed. You can see that it completed in 14.5 minutes. Everything is complete. Everything is green. Looks good to me. So we can go back and take a look. Here is our web console. It has completed. So this, we no longer need it. It's already powered off. The template is ready to go, ready to be provisioned, ready to use Terraform, for example, to provision that, and we're good to go. So hopefully this has been helpful as an example to show you how to use Packer within VMware to generate a Ubuntu 20.04 image. The same thing can be done with any kind of image. In previous videos, I showed you how to use Windows 2019, create a Windows image also with Packer, and also how to use Terraform to do that. But I didn't show you 20.04 or Ubuntu 20.04 before with the new cloud in it. So I wanted to record this video to show you this as an example. And in a subsequent video, I will use the same template we just created with Terraform to build a VM inside of VMware. Thank you for watching.